Our next talk is from Mike Arpaia of Collide Security, who has a seriously badass desktop background.
It's pretty awesome, right? Yeah.
And so he's going to be telling us about osquery and how to, in general, create sort of successful, robust open source security projects. So take it away.
I can hold this, right? All right. I'm not a big fan of podiums, so. So yeah, I'm going to talk to you today about creating successful open source security software. Before we get too deep into the talk, if for some reason this huge screen isn't big enough for you, or you want to reference the slides after I pass them, I've uploaded the slides to Twitter, so you can go and kind of go through them at your leisure if you don't feel like paying attention. And my Twitter handle is just my name, Mike Arpaia. So let me introduce myself to you guys. So my name's Mike, and I got my start in security in New York City. I grew up here, and I got my start as an offensive security professional working at some boutique consultancies in New York. And then I was a software engineer at Etsy, where I focused on creating like a custom in-house host intrusion detection system that we deployed at Etsy. After Etsy, I worked at Facebook as a software engineer, where I created a piece of software called osquery and widely deployed it at Facebook. I later became the manager of all of intrusion detection at Facebook. So host, network, email, application instrumentation, so on and so forth. And then I left Facebook several months ago to start my own company, where I'm the chief security officer, which basically means I'm a co-founder that got to pick their own title. And that's what I do now. So I'm not going to really talk about my company at all today, which is good for you, right? But yeah, so that's kind of my background and my qualification. I'm definitely not the world's foremost authority on successful open source security software, but I have created some really bad open source security software before, and I've created some open source security software that people think is pretty cool. So the general format of what I'm going to talk to you today about is why do I think the concepts of openness and security are important? So in addition to just openness of code and releasing source code, the concepts of discussing ideas openly, sharing intelligence, the general topic of openness and security, and why I think it's important. And then I'm going to give you a brief introduction to osquery. Has anyone here ever heard of osquery? Has anyone ever used osquery at their job or something? Oh, that's cool. A few. Nice. So there's a lot of talks, some of which I've given, some of which I haven't given, that talk about what osquery is, how it works, implementation details, how to use it. There was just a really awesome 2-day training given at BrewCon. So there's a lot of resources there for you to learn how to use osquery and get a lot of value out of it. So I'm not going to go over a lot of those details in this talk. I'll just give you a brief overview so we have a shared platform to have a dialogue about. And then I want to talk about that host intrusion detection system that I released when I worked at Etsy. I want to kind of talk about some of the decisions that I made when I wrote that, and then talk about why they were kind of a problem for its open source adoption. Now, there's many reasons why that piece of software wasn't a great piece of software, but I'm specifically going to talk about why it wasn't a great open source piece of software. And then I'm going to talk about how we rectified those design decisions in osquery when we released it, and some generic lessons that you can take out of that if you're going to either release your own open source security software, or if you have your own software that you already have released, maybe some things that you can do there as well that trial and error indicated was useful. And then finally, we'll talk a little bit about how we can, work together and kind of all approach openness and information security regardless of our skill sets. So first off, being open. Why is being open important? So we all use open source software. Here's a few of my favorite pieces of open source software. Some of them might be familiar to you, some of them might not be. But I really like all of the pieces of software on here. And this is basically the technology stack of my company. It's all open source and it's all awesome, and it makes all of our lives easy. And I can ask you to raise your hands and say who likes open source software, but it's it'd be a waste of time because you would all say that you do. And I'm here to tell you that, in my opinion, the secrecy in the information security industry has stifled a lot of the innovation that we've seen in other fields of computer science. If you look at like databases or artificial intelligence or just other generic fields in computer science, they've seen a lot of innovation because of all of the like foundational open source software that's existed. In databases, you know, we have MySQL, and MySQL and Postgres are kind of these competitors that both represent like the sum of our knowledge in relational databases, right? And we keep iterating on that. We keep getting better at creating relational databases. And that's really cool. But we don't do that in information security. You know, especially as defenders, we kind of like all think that we have the best ideas and then we implement them alone in our little corner, deploy them to our small companies, and then like no one really benefits from it. And that's generally how it works. And you may say, well, we have to do that because, you know, we have to be secretive. And I'm here to tell you that we don't. And you may not agree with me, but I'm going to try to convince you why. So let's do the math, as I like to say. So, have you guys ever heard of two guys named Dino Dizovi and Dan Guido? Yeah, they're pretty popular around these parts. So Dino gave a really awesome talk at Source Boston when he keynoted a few years, and it was called Attacker Math 101. And he basically laid out this platform for thinking about attacks. And he was mostly talking about the iOS kernel and exploitation of the iOS kernel, but his platform, I think, is a really awesome way to reason about attacks and defenses against them. So Dino created this like visual framework for reasoning about attacks, and I'll get to that in a bit, but basically the 2 points that Dino had out of all of this, and I want you to keep in mind as I walk you through this visual framework, is that it's like there's a graph that I'm going to show you that represents an attack, and attackers are always going to take the least cost path through that graph. And at the end of the day, the juice has to be worth the squeeze. You know, attacks cost money, resources, knowledge, general, like, you know, it costs stuff to carry out an attack. If any of you have ever like performed an illicit attack against a large organization, you know that it's not like just something you do for fun, or maybe it is. But yeah, the attack, like, you know, if it costs, Dino's main axiom that is that if the cost of an attack is less than the gain that you will get out of carrying out an attack, then an attack will occur. So it's all of these ideas about the economics of attack. So to drive this home a little bit, Dino's visual framework for talking about attacks kind of looks like this. You have a node on the left and you have a node on the right. The node on the left is where you start. The node on the right is your end objective. You're going to like get all the credit cards, or you're going to dump all the database tables or something. And in between the start of your attack and the end of your attack, there are objectives and there are obstacles you need to overcome. And depending on the path that you take through your attack graph, there might be more obstacles and there might be less obstacles. And his, like, you know, proposal is that attackers are always going to take the least cost path through an attack graph. So given this graph, it's pretty obvious that you know, the attacker is always going to take that bottom path. However, if we were to make that bottom obstacle like huge, almost insurmountable, then we can kind of force an attacker's hand to go the other way through our attack graph, right? Similarly, we can like influence the economics of this graph by adding more obstacles to this one path. So if we identify a path that's a little like too traversable, we can change it. You know, we can manipulate the graph to influence the economics of the attack, right? So the key point here is that as defenders, now, you know, I come from kind of a defense. I started off my career in offensive security, but for the past few years, I've been doing more defensive security. And the key point here is that, like, as defenders, the graph represents our infrastructure. And as defenders, we can control the graph. Thus, we can control the economics of the attack. And that's how, you know, defense actually happens in real life. It's not like super sensationalist, or at least it shouldn't be, but you reason about how attacks happen, you reason about where your organization is like most significantly at risk, and you make the attacks more expensive by manipulating the economics of the attack. That's how it happens. Pretty straightforward, right? So what does controlling the attack graph have to do with being open and openness and open source software, right? So my kind of assertion is that as systems become sufficiently complex and as they become sufficiently large scale, the software that we use to influence the economics of the attack, the instrumentation software that we use to instrument our production servers, or the packet capture software that we use and install into our production backbone. Like, all of these tools must become like pretty sufficiently advanced in the modern enterprise as we've gotten like pretty advanced with the way that we develop, design, and deploy infrastructure. So I'm saying that it's an engineering problem, and the future of information security is going to be written in Vim, not Emacs. Maybe Visual Studio Code, because I've been pretty into that lately. But yeah, this is just a screenshot of the GitHub security showcase sorted by stars. And you'll see osquery is first. That's really cool, although it's, although Metasploit's not too far behind. So we'll see. We'll see how that one goes. But basically, in order to create software which scales to the needs of the modern enterprise, we can't just be creating these solutions on our own at our own companies. So I think that we need to kind of take cues from other industries, like the databases industry, and create software which represents the sum total of our expertise in a certain topic, which is, I think, why kind of, osquery is really cool, because it allows us to kind of point to something and say, okay, here's like state of the art with like detecting attacks on, cross-platform infrastructure, and here's the best way we know how to do it, so let's double down on that or something. So another thing you can do is you can select some attributes from the running processes that are running, and you can specify, right, I only want to see the processes where the binary is in Windows System 32, and you can get a bunch of those. You see your SVC host over there. You got a bunch of cool stuff in there. This one might actually be a little harder for you to see, but basically, what this says is osquery and then quotes, select path PID from processes where path like C program data --JSON. So this is just me showing you that, like, you can take these SQL queries and you can run them, and you can just pipe them to osquery. You can run them as an argument. You can get the results back in arbitrary formats. You can just use them like in your scripts and your tools. You can do whatever you want, really. osquery is kind of like that utility knife that allows you to just like execute queries either interactively or from a tool or what have you, pretty easily against the host that you're currently executing on. It's an important differentiation. And this next slide is just me running that query and then running it again. So what you're seeing in the results here is path, program data osquery, osquery.exe, and a PID. And then I run it again, and you see the same path, but a different PID. And the reason why you're seeing that is because program data osquery, osquery.exe is actually where the osquery binary, which is executing this query, is on disk. So it's iterating the process table, and it's seeing that there is a process, osquery that's currently running, because that's the process that's running the current query. So it's kind of just to kind of like try to drive home the fact that when you run the query, it's actually executing the C code to go and enumerate the kind of relational data that you're looking for at runtime. So it's not like there's actually this, SQLite database on disk that has all of this information. It's just really fast. And when you run a query, it plans the query, and it uses there's kind of all these hooks into a SQL query engine that, go and collect all the data you want and do your statistics and aggregations using SQL. So it's really cool. There's a ton of tables. There's like over 150 tables across all the operating systems. So there's a lot of cool stuff you can do. If you go to osquery.io/docs, you can see all the tables. It's awesome. So osqueryd is kind of, I always say, if this was an episode of MTV Cribs, I would say that osqueryd is where the magic happens. So osqueryd is the really awesome monitoring daemon, which is like, osqueryd is what you would use if you had a large set of infrastructure and you wanted to monitor that infrastructure using the osquery concepts. osqueryd is the tool that you would use. Righteous. So osqueryd, yeah, I mean, that's basically daemon for low-level host monitoring, and it basically allows you to say, let's say you have a query that like exposes some really interesting information about an operating system. Let's say like select star from kernel modules. that's interesting. You know, that body of information is inherently interesting, and you're probably interested in knowing how the results of that query change over time across your production fleet, right? Like if new kernel modules are being installed on your web servers, like, you know, passively interested in that happening, right? So osqueryd allows you to take a query and say, all right, you know, here's the query, and with an interval, with a refresh interval of about 60 seconds or 10 minutes or an hour or once a day or whatever, rerun this query and emit a result log of how the results of this query change over time. So it allows you to express the capabilities that you want to track via a concise SQL query that represents the state of the world now, and then you can collect a log of how the results of that query change over time across all of your infrastructure, which is really cool. So the daemon takes care of you know, ingesting the schedule, we call it, and then scheduling those queries, splaying them across your infrastructure so you don't have like stampeding herd problems, and periodically executing them, storing the results in a performant local data store, and doing all that magic so that you get this like nice performant result log that you can run on all of your production software. Now you can, if you're like, well, that's cool, but I don't really want differentials. I just want all the data every, like once a day or something. Like I want a snapshot of all the apps that are installed on my laptops once a day because I'm trying to do inventory management. Then you can run a query in what's called snapshot mode. And that just skips the differential part and just outputs all the results all the time. And if you're not concerned about like throughput or something, so when you work at like a large company like Facebook and you have hundreds of thousands of servers, if you were to run all your queries with 1 second intervals in snapshot mode, like you'd melt your switches, right? So you have to be a little more conservative with your bandwidth. But if you don't care about that, or like the use case determines that you want actually all those results all the time, then there are modes for that. osquery also has client APIs for doing distributed queries. So you could be like, oh, that person is doing something sketchy on their laptop. Like, let me see what's going on. Or let me, like, there's some, you know, weird DNS connections coming every 30 seconds out of that person's laptop. Let me check out what's going on. There are client APIs for that allow osquery to talk back to a distributed query server where you can where you can interact with and distribute out queries so that you can interrogate hosts and do cool stuff there for like instant response type stuff. This is a screenshot of the app that my company is building. It's called Collide, right? And it's basically, you know, just writing a query, and then you can select which targets you want to run that query on, click go, and you can like mess with the results and sort them and search through them, save the queries, all that cool stuff. So it's like the back end to osquery, basically. I'm just kind of giving you guys a whirlwind of osquery features right now. So there's a ton, like I can talk to you for hours about osquery features, but I'm not going to. So just a few left that I want to cover, really high level. So let's say, for example, there's a table called USB devices. And let's say you were running a query against USB devices every 60 seconds because you wanted to see when someone plugged in and unplugged a USB key into, you know, your finance team's laptop. Well, let's say you're running that every 60 seconds, then you would only see that result if the USB key was actually plugged in and then when an execution of the query happened, and then unplugged when a different execution of the query happened, right? And so the way we get around that, the way we solve that use case is we have this like internal system in osquery called, that we don't really have a great name for, but it's been called the host event pub sub system, where basically we use operating system APIs like iNotify for file changes or libudev for devices getting added and removed. All of those like C APIs expose kind of like, some of you might be familiar with some of the event-based APIs that those libraries expose. So we use those and basically queue results, and as events happen, as indicated by those APIs, we buffer those results, and then every 60 seconds you can query the events that have occurred. So you can do something like select star from USB events, and that will not be lossy, and you will be able to see whenever someone plugged a USB key in and out. A colleague of mine does a demo where he like runs a query in osquery and then like plugs a YubiKey in and unplugs it and then runs the query again for USB events, and then you see the two events that were in there because of the pub sub system. I don't really do live demos too much, so I didn't do that. But it can be done, it's cool. There's also file integrity monitoring. It's like a little known feature of osquery. If you've ever like used a FIM or something, if you've ever been like, oh, I wonder, like, it's probably interesting when the files in /bin change in on like my production servers. I'd be interested in knowing about that. You can do that. You can use wildcards to like hash the downloads on your users' laptops or something. You can do stuff like that. And all of this kind of exists within this really extensible plugin system. All the tables are plugins. The way that osquery pulls configurations is pluggable. The way it logs is pluggable. For example, maybe in your corporate environment on laptops, you want to pull your configuration data from disk, but in production, you want to pull it from Zookeeper or something, because that's how you distribute configurations in production. So there's this kind of runtime plugin system that allows you to just arbitrarily define, oh, in this environment, I want to pull from here, and this one I want to pull from there. There's a bunch of plugins that exist, and you can add ones for your own organization. Like at Facebook, we had our own internal plugins that we added for using like Facebook internal technology for doing all of this, and it was really cool. So yeah, that's like the last big feature that is kind of like, and if any of the other things don't really work for you, there's this really awesome plugin system. Cool. So now I want to go through, I'm going to take a few deep breaths. And I want to talk to you guys about a few of the like key design decisions that we made when we were designing osquery that were lessons learned from a previous host intrusion detection system that I worked on called MIDAS, which stands for Mac Intrusion Detection Analysis System, which we released when I worked at Etsy, and is currently still available online, but it's like archived in a different branch. So we released, like I said before, there are a bunch of reasons why MIDAS wasn't a really awesome piece of software from like a software engineering perspective. But I'm going to talk about why MIDAS wasn't a great open source piece of software. And specifically, I want to talk about the 5 like topics that I want to talk about, where I'm going to enumerate what the problem was, what the solution that we came up for it was in osquery, and what the abstract lesson you can take from that. Those 5 topics I want to talk about are exposing the capabilities of your security tool safely, reducing the engineering overhead for the users of your tool, improving the development culture so it makes it easier for both the developers and the users of the project to kind of maintain a certain level of openness and transparency in the way they make decisions. Improving the runtime performance. Like, I think performance is super important, and some people don't. I'm willing to have beer and disagree with you, but I'm going to talk about things that we did in MIDAS that made it not very fast, and things that like huge design decisions that we made in osquery to make it super fast, and why that has been really awesome for us. And then finally, distributing package downloads is a thing that no one does, but I think is really important. So I'm going to talk about that. So the first one, exposing capabilities safely. The problem with MIDAS was we kind of released this software, and in order for it to be useful, so basically the way MIDAS worked was it had this like capability sharing system where you shared capabilities as like these Python modules. And it's not so different, I guess, from like the kind of approach that pieces of software like Volatility have taken, where you have these capabilities that are represented in code. But what this meant was that, you know, we had a bunch of them internally, and we didn't really want to share them with other people, because if we shared this capability, everyone would know exactly what we were looking for on hosts. And so we were like, okay, well, we'll just release this framework, and then maybe people can write their own plugins, and maybe people can write abstracted ones. So we didn't really release many example modules, and that dramatically limited the out-of-the-box utility of MIDAS. People saw it on Twitter and they thought it was interesting, but when they went to the repo, there was nothing that they could download, play with, and get value out of, right? So in osquery, the solution that we came up for this was SQL. So I always like to say, like, SQL allows us to give away the answers to all of the questions without having to give away the questions, right? So, you know, osquery has a launchd table, which is how processes are scheduled on OS X. But just because that osquery has a launchd table, you can't make any conclusions about what Facebook does with that data or how they look for attacks in that data. Whereas if we would have released that capability in MIDAS, it would have been very clear what we were doing with that data. So, giving away the answers without giving away the questions and still like wrapping it up in a really cool user experience was a big win that we took out of that. And I guess the lesson that I'll tell you all is like users of your software really care about OPSEC, and so do you, and you probably should. And capabilities are always seen as kind of these like operational secrets, and I think that's a lot of the reason why there's been so much focus in the security industry over the past several years on signatures and standardized signature formats so that we can like facilitate the sharing of Intel via trusted streams while creating software that generically consumes them, right? This is a big thing that a lot of people think about in our industry, and you should think about it too when you're creating your software. And the other thing is that your tool needs to be immediately deployable and useful. If you're creating software and it's not, and you're throwing it on GitHub and it's not like, defenders have a limited attention span when it comes to using your software, as well as if you want it to actually be used in, production context to make the internet a safer place at general organizations, then, the normal security engineer that works there needs to be able to take it, use it, get value out of it, show it to their peers and like senior management and say like, hey, listen, I found this awesome thing on Twitter. I used it and I actually found stuff. Like, how awesome is that? Like, we should totally use this. And that's how you're going to get that kind of adoption. The next thing that I think is really important is reducing engineering overhead. So in MIDAS, like I said, capabilities were written as Python modules. And it required like pretty complex code to solve pretty simple problems, relatively simple problems. And security professionals aren't programmers. Operations engineers aren't programmers. People that are generally responsible for reasoning about the instrumentation of operating systems at a large scale aren't programmers, and they don't really want to be, right? So giving them programmatic interfaces to things, while it may be fun and the easy out, I implore you to kind of like think more about creative ways to approach that interface. So in osquery, that was a big reason for SQL. So, I like to say low-level operating system analytics with attention to user experience. So this one query here, select address MAC, count MAC from ARP cache, group by MAC, having count MAC is greater than 1, is a really simple query that finds ARP anomalies from the host perspective. And that's like a pretty, like, not so trivial thing that you just did in a pretty simple, like, easy to grok query language. Now, I'm not saying that SQL is the best query language. I'm kind of into query languages, and I have all the same gripes with SQL as you do. But the thing that's important is that like almost everyone knows SQL. So when you give them a tool that has this interface that they're already familiar with, it reduces the whole, like an entire barrier to them using your tool and to them actually adopting it. And I think that's really important. So the lesson here is, I would say, is to ruthlessly prioritize the user experience. You're not always going to get it right, but you'll be a lot better off if you at least like try a lot. CLIs and code libraries, like they all have user experiences. And I've seen a few talks so far today where authors of their open source software have talked about, here's the API that you would use to extend this feature. And here's here's what you would run when you want to perform this kind of action using my tool. And as a developer, like you're creating, similarly to if you were writing a pretty web app, or you're writing a CLI tool, or you're writing a code library, those things have people that are going to use them, and people have like human computer interaction, like things that they're going to experience when they use technology. And like you should think about how people are going to feel when they use your library, and like is the API consistent, and when I'm extending these base classes, are they all, does it make sense that I would do this, like based on everything you've told me thus far? Is this the obvious thing for me to do, right? And the answer should always be yes. And don't be afraid to be creative. A query, like creating a query language to solve a user experience problem and concurrently a performance problem, and I'll talk about that later. But, that was kind of out there when we first thought of it. But it worked, it was like kind of creative. but it worked and it was really awesome. So the next thing I'd say is development culture. So this is probably not a problem for you if you're a student or if you're doing something in your free time, but if you work at an organization and you use tools at your company that you've written on like your company dime and you want to like get into the open security game and start open sourcing some of your stuff, this is really important. So MIDAS, we wrote it internally and we had it in internal repos. And when we open sourced it, we kind of cleaned it up and put it on GitHub when we did like a manual code sync and got it all out there. And it was terrible because the code base began to drift. We got contributions from the open source community, and we hadn't set up infrastructure for syncing those changes in. And that wasn't awesome. And we weren't really updating the code base because we hadn't set the bidirectional synchronization up via automated tooling. So everything just kind of got stale really quick. And the solution is now with osquery, 100% of the osquery engineering happens in the open on GitHub. And when we started working on osquery, I knew that I wanted to open source it from the beginning. So fortunately, like we created the repo on GitHub, and you can like go to commit 1, and you'll see like the code dump of my initial like proof of concept. And then it, you know, there's like 4,000 commits after that. Most of them aren't from me. So that's cool. So the lesson there, I would say, is to think about the community of people that are going to use and contribute to your tool, and think about, you know, like if you and another person are working on this. There were tons of times when like myself and the other osquery team at Facebook would like have a conversation, and then we'd be like, hey, we should really have this conversation in an issue, even though it'd be slightly less efficient for us to do so. But because tons of people from the community would chime in and be like, hey, that's a really good like idea you guys have, but it kind of kills this use case that I think would be really cool. So how about we incorporate that in? And we'd be like, wow, we didn't think of that. We don't really use osquery for that. Like that's an awesome perspective. So it turns out diverse perspectives are useful, and you should try to harbor them. Who knew? And never launch a product without which is synced via manual code dumps. It's just not going to happen. Always set up the automation up front. Always launch with the tooling. A user's first experience interacting with your software is like going to you know, hold a lot of value, and the first time they interact with your software is probably going to be when you launch it. So yeah, definitely do that. On to the performance. So I know I'm probably going to like break a lot of hearts here, but MIDAS was written in Python. Python has a global interpreter lock, which some of you may or may not be familiar with. Operating systems are not written in Python. Surprise. So there's like, when you're writing operating systems instrumentation software, there are a lot of APIs that allow you to, you know, instrument the operating system in various ways, and none of them are written in Python. They're all written in C, C++, or Objective-C. The other thing about MIDAS was that it, like the design patterns that we set up in the application led to us kind of like, all right, since Python doesn't have real threads, and we have all of these compute heavy things that we want to do, we're going to exec a lot of processes. And you might be like, well, operating systems are fast, you know, exec VE isn't super expensive, so we can get by with just a few of them. But as your software grows, it quickly becomes really unmanageable. And if the way that you're going about acquiring new data is by execing a ton of processes, you're going to feel that really fast. And that's a huge bummer. And then the other thing is MIDAS used SQLite as its local data store. And SQLite's not thread safe, and it doesn't support concurrent access. So all of these like different processes that we were spawning out to do this instrumentation had to then funnel back into one and serially access the data store, because SQLite's not thread safe. Now, I'm not talking shit on SQLite. osquery uses SQLite for its query language, but not for its data store. And the solutions to that were, you know, when we were working on osquery, I needed it to be faster than MIDAS was. MIDAS was so slow, and it used so much CPU, and like Python, I just had like such a bad experience using Python to do that kind of instrumentation. So I wanted native performance. You know, I wanted it to be as fast as if I like hand wrote all of this instrumentation in C and C++. But I knew that if I told my team at Facebook of security engineers that in order to use our host instrumentation tooling, they needed to write C, they would tell me to go take a walk, right? It wasn't going to happen. So I like for weeks, maybe for weeks, I had this like conflict of like, I didn't know what to do. And I came up with the idea of, I didn't want exec processes. I needed it to be as fast as C, and I needed it to be easier to write than Python. So we wound up coming up with the using SQL and using the SQLite query parser and query planner and injecting ourselves into the query execution process and basically stealing execution from them using this little known API that they exposed for doing just that. And it was awesome because that's all written in C. We wrote a really intuitive C++ API for gathering these the various data into really nice C++ data structures. So it's all of the the developers get to write C and C++ and it's really fast. The users get to write this really simple query language that they already understand and is well documented. Everyone wins, right? It's really awesome. And the other thing is a lot of people hate interviews where they have to write, a tree or invert a tree or reverse a linked list or something. You're like, oh, I'm never going to actually use any of this shit in real life, right? But, we used RocksDB instead of SQLite for local data storage. And RocksDB under the hood is an LSM tree. Which are super optimized for heavy write workloads. So because a lot of the data in osquery is kind of ingesting a lot of data, especially in the file and file integrity monitoring, a lot of that is just things are coming in and we need to stream them to disk. It's a very write heavy workload. So it's one of those times where it's actually useful to pay attention in school and understand the differences between all of these different kinds of data structures and algorithms, coming from the college dropout in the room. I hope you take that to heart. So I guess my lesson would be to take performance seriously because it's important. And one of the biggest things that people have really liked about osquery is that I can go to them and say, hey, the same server that serves your newsfeed runs osquery. And, Facebook has a whole team of crazy performance engineers that care a lot about the performance of the software that we run on Facebook production servers. And when I told them that I wanted to run this auditing security software on 100% of our production servers, they were like, whoa, talk to me about this, right? So we had to have really defensible, I had to walk them through at one point the entire startup process of the osquery process. And I had to from memory tell them what was on the heap at every different point, right? So there are all these kind of things that we've done with osquery to make it really optimized and really low memory utilization that have made it really awesome and really safe that even if something does go wrong, it's going to take down a worker process and respawn it instead of taking down the whole system or using up all of your IOPS. So yeah, think about it a lot, think about performance, but don't think about it too hard. It's more important to ship your product, right? So you should care, but don't care too much. And the way you should solve that problem is when you have something questionable and you understand the impact of that decision, put it behind an interface and then document why it sucks and then come back to it later and then fix it, and it'll be behind this kind of abstracted interface that allows you to take out the old implementation and put in a new one. So whenever you have things like that, you can put them behind interfaces. And for example, RocksDB in osquery is behind an interface. And it could be subbed out at any time. It hasn't been because it was a good decision. osquery still doesn't shell out. It doesn't exec fee anything except when it starts and it forks itself to create a worker process. That's the only time it execs. However, a lot of parts of the core query language infrastructure have been subbed out, and those were also behind interfaces. So it's fine, right? So you make decisions, make good decisions, but isolate them in case they're not good decisions. And then I think this is the last big thing that I have for you all, and I think it's the biggest plague of open source software in general. I'm getting really serious about this one, but package distribution is a huge problem. So in MIDAS, we just had a repo on GitHub, and if you wanted to use it, you had to clone it, and you had to basically like, the barrier to using the software was the same barrier as contributing to the software, right? And that's not awesome. And the solution that we came up with osquery is, we have an osquery.io/downloads page, and we have, instructions on how to build it from source, but we also publish OSX packages, we publish, RPMs, we publish debs, we also host, like Yum repositories and apt repositories, because if reason about who your ideal audience is and how they want to consume your software. If you're creating production infrastructure software, then people who install software and production servers use things like Chef or Puppet, and they, add an apt repository and then pin to a version. And then when they're comfortable with an upgrade, they'll upgrade a version, or they'll upgrade a subset of hosts. Like, reason through the general process of how people are gonna use your software and adhere to it. If you were creating a JavaScript library, you wouldn't not put it on NPM. If you were creating a Python library, you wouldn't not upload it to pip. So if you're creating an executable, distribute packages for the operating systems you support. If you don't, you're just being a negligent software author, in my opinion. Sorry if that's a little inflammatory. Yeah, don't expect enterprise adoption without mature distribution. I think it's really important. And take hints, look at tools that you think have been really successful. I've listed the osquery one, of course, right? I'm a little biased, but I've also listed HHVM, which is another Facebook project, as well as Vault, which is the secret management project. And they're all distributing packages for the operating systems they support. And they all have a whole lot of adoption. So to recap, expose your capabilities safely in your tool and preserve OPSEC and reason about OPSEC and make sure that your users are going to be comfortable using your tool and that they won't feel as though it's harming anything at their organization. And ruthlessly prioritize making the UX really intuitive and really easy. You might be an expert at foo, but the people that use your tool aren't going to be an expert at foo. That's why they're using your tool to do it and not doing it themselves, right? Make sure your development culture makes the process of open source easy. This is especially important for companies. If you want open source to be a good experience for you, you need to invest up front in the tooling so that that's going to be a good experience for both you and your users, and that they can look at the commit log and see a lot of regular commits and interact with the people that are building it and stuff and contribute to the core conversations that are happening. You should care about performance and use abstractions when you need to make trade-offs for those reasons we just spoke about. And binaries and libraries should definitely distribute packages for the operating systems they support. And I think those are the key lessons that I have for you today. So I would say that, imagine for a brief second that, we have this operating system instrumentation platform. And imagine a world where you have defensive security engineers that are deploying this piece of software to, their hosts and keeping their clients and servers safe using this operating system instrumentation piece of software. And then you have offensive security engineers that are kind of doing their cutting edge offensive security work. And as they're finding vulnerabilities and identifying insecurity in the world, they're adding ways to understand these facts about operating systems into this operating system instrumentation software. So you have offensive security engineers that are finding vulns and adding ways to detect those vulns into software. You have defensive security engineers that are continuously exhibiting good update hygiene and updating their software and continually deploying it. You have entrepreneurs that are using open source software to kind of, as the foundation for their agents, so we're not all running rootkits on our production servers. It's just when everyone buys in to a specific ecosystem in open source, even from many different walks of life or from whatever your kind of expertise is, it's valuable for everyone. So I would encourage everyone to kind of buy into a single open source way of doing something and really drive it home. And with that, I'll take questions if there are any. If not, we can just go get coffee.
I guess I can start off with some questions. First of all, fantastic talk, and I already have a bunch of things that I now realize I should go and fix about my own project. So thank you. So one thing that I was curious about is, so you've now worked on osquery at Facebook, which is sort of the archetypical megacorp, and now it's sort of in like a startup environment. Could you say something about sort of what the difference is on working on an open source project in each environment?
Yeah, I mean, I would say that Facebook is an interesting example in this case specifically because Facebook has one of the largest, most robust open source portfolios in the world, right? So they have React and HHVM and Folly and all of these really popular open source libraries, and they have a very well established mechanism of open sourcing software. So when we decided that we wanted osquery to be open sourced, there's an open source team at Facebook who creates infrastructure for synchronizing internal repos with public repos, and there's a allocated budget for getting really awesome logos and stuff. There's all of this crazy stuff that makes it really easy for you to create open source software at a company that has a well-established record of releasing successful open source software. So that's interesting. At a startup, I would say the main kind of conversation that you have around creating open source software as a part of your business model is that you reason a lot more about what it means to have intellectual property and what it means to your business model and the valuation of your company if you release certain things permissively. And when you go to investors, if everything that you have released is released under GPL or something, nobody else can make money from it, and neither can you, right? So that's no longer intellectual property that you can really use to make a profit, and that influences your valuation in modern capitalist ecosystem. So it's a whole different set of I really love open source, so it's been really interesting reasoning about venture capital and how that influences open source. Where at Facebook, it was just pretty awesome. It was pretty fun. There were also some legal things as well, since Facebook has a lot of lawyers, and you may have seen the Hacker News flame war that went down a few weeks ago, where people kind of actually read that patents grant that Facebook distributes with all of their open source projects, that kind of says that if you sue Facebook because a piece of open source software that they've released, and if you sue them that it infringes on a patent you hold, you can no longer use any piece of Facebook open source software. So if Facebook releases something and you feel as though that infringes on a patent of yours and you sue them for it, you can't use React in your front end, right? So it's just one of their ways of legally defending themselves against certain things like that, and it's kind of a bummer. And we actually wanted to contribute. It's kind of off topic, but we wanted to get another big Silicon Valley tech company to contribute to osquery, and we actually got a we got to change around the patents grant so that we could allow more open contributions from other companies without them having to take on too much legal risk. So that was a really cool thing that we were able to influence at Facebook. But yeah, it's really different. It's really different. And it's all really interesting and fun.
Thank you. All right. We have more questions? Okay.
So you do a lot of, you did do a lot of red team exercises at Facebook. How have red teams sort of, because you use osquery to do proactive security and gain awareness in your infrastructure, but how have red teams bypassed in the past, either at Facebook or other companies?
Yeah, it's a really interesting question, and I think this question is going to wind up being more about red teams than osquery. But I used to work at a company called Etsy, which is based in Dumbo, right down the block, and we did red teams there. And the way it would work is we would give basically an attacker a provisioned laptop and tell them to go crazy and we wouldn't know what it was. But if we detected them, that would be like, awesome, our detection systems worked. And then we'd kind of just let them go, see what else they triggered. If we missed stuff, then we'd know to augment our detection systems and so on. And then we'd also want to see how far they got, right? And we were mostly using red teams as a way to test our detection systems and see how effective they were. At Facebook, the way red teams work are we would just give attackers a foothold. We'd basically give them a shell in a production box, and we would allow them to bypass all detection because we weren't interested in testing how effective our detection was. We were interested in testing how effective our response capabilities were. So a lot of organizations kind of deploy tools to instrument operating systems or networks or what have you. But there's also this whole class of people that take SANS courses and are really into the DFIR ecosystem that are incident responders, right? And their immediate value comes when a breach occurs. So at Facebook, and Facebook and banks and many large organizations have teams of incident responders. And in order to red teams are more of an activity to help them keep their skills sharp rather than to test the defensive mechanisms that we had. Because as defenders, I can talk to you over a beer about all the ways that someone would bypass osquery, right? Or would be able to turn it off on an operating system that had SE Linux installed and was configured in these ways. We can just intellectually have that conversation, whereas something like allowing people to exercise their instant response skills is something that's a little less tangible. So at Etsy, we did do that to detect our detection systems, largely because we were just less certain of what we actually would catch, or we wanted to observe new ways that attacks were being carried out so that we could add stuff to our detection systems, but that really wasn't the objective at Facebook. I don't know if that answers your question.
Yeah, thanks. Also, how far along earlier in the osquery project did you email other security engineers at other companies and say hey, do you want to collaborate on this or things of that nature?
So pretty early, I'd say pretty early in the project's lifecycle, I started having conversations with people that worked at other companies where, I had a proof of concept maybe, and I would pitch it to them as hey, I'm making this. I think it'll be widely applicable to other organizations. Let me get a gut check from you. And they would be yeah, that sounds cool. And they'd basically give a thumbs up on the idea. And that was just to get some more opinions on the design. But I think we were pretty happy with the design and we had a good intuition for it. So we didn't do that too much. But then when we actually on October 29th of 2014, when we announced osquery as open source software, in the months following that, myself and other members of the Facebook security team would routinely drive around Silicon Valley and go have lunches with other security teams, or have video conferences with other security teams and talk to them about their host intrusion detection. We were basically salesmen for a while almost, where we were just kind of having all these conversations about why we thought osquery was awesome and why people should use it. And now we don't really do that anymore because there's a community and there's a Slack channel and there's a website and there's better documentation and there's kind of it's proven itself to a degree. But that wasn't always the case. And there was definitely a bit of time where we had to, when you were, the head of open source at Facebook often says the hard work starts when you release your product, not when you're developing it or when you're getting ready for it to open source. A lot of people think it's a huge party when you release a piece of open source software, but that's when the real work starts, right? So yeah, it's like having a baby, right? I always say it's like releasing a piece of open source software is like having a baby. It's you put several months of effort into creating this thing, and then you do it and it's really exciting, but now you have this infant, right? And it could not really go well if you don't pay a lot of attention. And then if you put a lot of effort into it and you harvest this thing that you've created into something that's a blossoming young adult, then then you could reap the benefits from it. But it's a lot of work over a long period of time.
Thanks.
So I actually just want to piggyback on that question. You mentioned things like, Slack and things like that. And so one thing that I feel like I've noticed is that there is sort of a proliferation of different ways that users can sort of get in touch with you and get help on your project. You can do an IRC channel, a Slack channel, a mailing list. Just use the issue tracker on GitHub. What do you think is sort of more effective? What are the downsides and upsides of these?
Well, when we released osqueryd, we had a mailing list, and we had, we mostly just had the mailing list. Well, at first we just had issues, an IRC. We started an IRC channel. And then we were like, well, what if there's like a security vulnerability? How are we going to announce it? Would we just create an issue and leave it open and hope that people saw the issues? So we were kind of thinking about like general announcement strategy. So we created a mailing list. And ultimately, the end of the story, so that's the beginning of the story, right? The end of the story is that we stopped using the mailing list, and we stopped using IRC, and now we just use Slack. And I would say that I don't have like that's worked for us. We use issues really heavily to like document technical problems and talk through like proposals for ideas in a more formal setting. And then we have a Slack where people can ask questions and get help and generally just like talk about the weather. And I'm not going to say that that's like the best way to do things, but I will say that like you're going to make, like everything else in your open source software, like you're going to make decisions and they're going to be wrong. And you need to be comfortable changing your mind and being able to like be agile and recover. Like, all right, we had a mailing list. The mailing list empirically doesn't really seem to be working. I know I spent a long time that one night setting up the mailing list, but let's try this other thing. Oh, this thing is working. I'm glad we did that. So yeah, I would just say like, I don't have a good answer for you on like what's always going to work, but I will say that just try stuff and get feedback from your community about what works for them and then just double down on that.
All right. Are there any other questions?